In the previous problem we have solved non-sway frames in all the previous videos. Okay, I have solved two of the non-sway frames. Now I want to move on to the sway frames. Okay, so non-sway frames are frames which do not sway or do not translate. Okay, now sway frames are those which sway. Okay, basically, which means that they can translate. Okay, so to make you understand what is sway and non-sway frame, what I'll do is I'll take an example of a structure and I'll try to explain you. Okay, there are several conditions in which a sway happens. Okay, first let us try to understand what is sway is. Okay, so to understand how the sway will happen, what we need to do is to understand this given figures. Okay, imagine this is the sway, this is the frame we have, and if I apply a horizontal force somewhere here, okay, you can apply a horizontal force anywhere you want, in this direction or this direction, anywhere you want. Okay, you can imagine what kind of translation that will take place for this given frame. So what basically happens is, if I try to apply a force in this direction, this frame will tilt towards this direction. So this tilting of this frame, okay, we call it as sway. Okay, it is swaying in this direction. Now if I apply a force in this direction, it will sway in this direction. So a sway will take place when there is a horizontal force being applied. Okay, now you may be thinking that whenever there is a horizontal force, there will be a sway. No, you need to also understand some symmetry conditions. Now for example, if I apply a 10 kilonewton force over here and the same 10 kilonewton is applied in the same direction, okay, or at the same point opposite to it with the same magnitude, then you can find that both are symmetric in nature. The force that is applied in this direction and the force that is applied in this direction are acting on the same plane, and their magnitude of force is also same. In that case, this structure will not sway. So you need to look into the figure, into the frame, and try to evaluate whether the sway will happen or not. Now imagine if this is kept 5 kilonewton. So it means what? There is a net 5 kilonewton which is acting in this direction, right? So in this case, again the sway will happen. Now for example, if I apply force somewhere here, okay, this I apply as 10 kilonewton, then again the sway will happen. So you need to also try to understand physically whether the sway will happen or not when the horizontal force is applied. Okay, but if the force is symmetric on either side of the column, then we can say that the frame is not undergoing any kind of sway. And there is one more condition in which in the previous video I have tried to solve. What I have done is I have provided a support here. If I provide a support here, what will happen? This support will create a horizontal reaction like this, and it will avoid the sway which is happening in this direction. Okay, so henceforth the first condition is, when there is a horizontal force applied, the frame will tend to sway. The next condition, so as you can see in this, this is our second condition that I am taking. In this you can see the length is not same. Okay, even though the horizontal force is been not applied, but the length of the columns are unequal. Okay, the length of this column is shorter compared to this column, and this column is longer compared to this column. There creates the unequal lengths. So because of unequal length also the sway will happen. Okay, so whichever is the longer length, as you know that there is a buckling condition, right? Shorter columns do not undergo buckling. Okay, longer columns undergo buckling. So this column is susceptible for buckling. Because of that, there can be a sway. Okay, this is another condition. Now going to the third condition, which is this one. So in the third condition, what happens is, you can try to understand the section of these two columns. This is I, this is 2 times of I. It means what? The cross section of this is greater than the cross section of this. So in that case also the sway will take place. Okay, there is another condition of foundation. If the foundation here is weak, okay, if this foundation undergoes the settlement or translation, then again the sway will take place. So these are some of the conditions in which the sway will take place. First is, if the horizontal force is applied and there is no symmetry in the force that is being applied, in that case the sway will take place. The second condition is if there is an unequal length, and then the third one is the unequal cross section. Okay, the fourth one you can consider that there is a translation or sinking of any of the columns. So in all these cases the sway will take place. Okay, so from now onwards we will try to understand or analyze the structures or the frames which are undergoing the sway. Okay, so I hope this is very much clear. The next thing is we'll take this problem. Let us try to understand this problem. Now these are the columns that I have, column AB, column DC, and there is a beam element called BC. Now the load that is being applied is not at the center. Okay, now for example, if this concentrated load was acting at the center, which is 3 meter from B or 3 meter from C, if it was acting at the center, the distribution of force or the distribution of reactions would have been symmetric. In case of symmetry, as I told you earlier, this frame may not undergo any kind of sway, but as of now this 50 kilonewton is applied at a distance of B, at a distance of 2 meter from B and 4 meter from C. Henceforth this load which is applied, the concentrated load being applied, is not symmetric in condition. When it is unsymmetric in condition and there is no support at any of the joints, then we can try to evaluate that this structure is supposed to be sway. Okay, supposed to undergo sway. So now first thing what we need to do is to identify the static indeterminacy and kinetic independency of the structure. So to understand both of this, what we do is we'll take the structure and we identify the total reactions that will develop, and also we'll try to understand the elastic curve. So first of all, let us try to calculate the static indeterminacy. To calculate the static indeterminacy, first let us take this frame and we'll try to understand how these supports behave. So this is your support, which is fixed support. This fixed support is having three reactions: vertical reaction, horizontal reaction, moment reaction, VA, HA and MAB. Similarly, at the D joint there is VD, MDC and HD. Okay, these are the three reactions that I have got. Okay, three reactions. As you know, we are considering HA and HD, so that's why I have to consider the third equilibrium equation, which is summation of horizontal force equals to 0. 6 minus 3 is equals to 3. 3 is your static indeterminacy. Now going with the kinetic indeterminacy, what we do is we need to solve the elastic curve of this. So as I said that this will undergo sway. I do not know in which direction the sway will take place. It may sway in this direction or it may sway in this direction. I am assuming that the sway is going to take place in this direction. Okay, it is basically an assumption. Okay, so if it sways in this direction, assuming it to sway in this direction, I know that this beam element is rigid element. Rigid element means it will not undergo any kind of compression or change in length. So whenever there is a sway of columns, the length of this beam will remain same. Okay, whatever the length of the beam was there in a original structure, after the sway also the original length will remain same. So in that case, the value of delta, which is the translation that is taking place at joint B and the translation that is taking place at joint C, will remain same. So I can write over here that delta B is equals to delta C is equals to delta. So it means what? There is one translation, one horizontal translation, which is equals to delta. Okay, now going to joint A and D, as we know they are fixed in condition, so we know that theta A is also equals to 0, theta D is also equals to 0. Okay, now these two B and C are internal joints. At that point we will have the slopes. Okay, so we will have the slopes, and the slopes are theta B and theta C. So the total kinetic indeterminacy of this frame is delta plus of theta B plus of theta C. It means 3 is your kinetic indeterminacy, and those kinetic indeterminacies are theta B, theta C and delta. Okay, so it means what? There are three unknowns you need to solve. One is theta B, the other one is theta C, and the other one is EI delta. Okay, so in the slope deflection equations, these will be the unknowns, and these are the unknowns which we are supposed to solve. Okay, next, as we know in this column is not subjected to any force, horizontal or any force, and similarly for CD also there is no force being exerted on the column. So it means what? The fixed end moments for MFAB and MFBA is equal to 0, MFBC and MFCD is equals to 0, and there is a vertical, the concentrated force is acting on the beam C, beam BC. So I'll first calculate how much is MFBC and MFCB. I hope you know how to solve the fixed end moments. We have already solved in the previous cases. I hope you remember that. So W into A into B square divided by L square. 50 into 2 into 4 square divided by 6 square will give you MFBC. Similarly, we can calculate for MFCB by 50 into 4 into 2 square divided by 6 square will give you MFCB. So once you calculate the fixed end moments, next step is to determine the slope deflection equations. Okay, so let us start with the first slope deflection equation, which is MAB. Okay, so let us write the equation, generalized equation. MFAB plus of 2EI by L into bracket 2 theta A plus theta B minus 3 delta by L. So as we know theta A is equals to 0, we will cancel it out. So we know MFAB is also equals to 0. I have substituted 0. Now 2EI divided by L is how much? 6. Okay. Theta B minus 3 delta by L. After simplifying, I have got the equation for MAB. Now similarly, we can solve for MBA. In case of MBA, instead of theta B, it will become 2 theta B. After simplifying, this is the equation for MBA. Now we can solve for MBC. Okay. In MBC, you try to observe this is MFBC, which you have got, which is 44.44 plus of 2EI by 6 into bracket 2 theta B plus of theta C. Both theta B, theta C exist. Minus 3 delta by 6 is there. Okay. Now we are not considering delta here. Why? Because translation is only taking place in columns. There is no translation in case of beam. So delta for this equation will become 0. You try to understand this concept. Okay, this is very important. The translation, whatever the translation that is taking place, is only in the columns. You can see here, only the columns are getting translated, but the beam is not getting translated. Okay, so if the beam is not getting translated, there is no delta in the vertical direction. The delta that we have written here is the translation that is taking place in the horizontal direction. There is no delta in the vertical direction. Okay, so that's why this delta is equals to 0. Okay, after simplifying this equation, this is what I got. Again for MCB, this is MFCB, which is 22.22. After simplification, this is what I get. Going to MCD, for MCD what we need to do is to go to these 2 points. So MCD is equals to, as we know, MFCD is equals to 0 plus of 2EI by 6 into bracket 2 theta C. Okay, and as we know theta D is equals to 0, I have eliminated that. Minus of 3 delta by 6 is there because this will also undergo translation, minus 3 delta by 6. After simplification, this is my MCD. Similarly, we can write for MDC also. So MDC will be EI theta C divided by 3 minus of EI delta divided by 6. So these are the 6 slope deflection equations which are generated for member AB, BA, BC, CB, CD and DC. Okay, I hope this is clear. If you have any doubt, you can ask me in the comment section. So once we have solved all the slope deflection equation, next step is to determine the equilibrium equations. And using those equilibrium equation, we are going to solve all the 3 unknowns, which is EI theta B, EI theta C and EI delta. Okay, 2 equations you already know, but there is a third equation that I have to tell you so that you could be able to solve all 3 unknowns. So the first 2 equations which you know are like this. Summation of all the moment at B and C is equal to 0, which means MBA plus MBC should be equal to 0. Similarly, MCB plus MCD should be equal to 0. So I do not have the slope deflection equations because I have erased it. So you can go back and look into your notebook and find out whether this equation is correct or not. Okay, this equation comprises of MBA plus MBC. So this is my first equation, which is the first equilibrium equation, which is MBA plus MBC is equals to 0. Next, going to MCB plus MCD equal to 0. This is the equation which has been formulated by substituting MCB plus of MCD. Okay, so these are the 2 equilibrium equations which we have arrived at. Okay, then there is a third equilibrium equation which is required. So the third equilibrium equation which I am going to utilize is called summation of horizontal force is equals to 0. Okay, that is my third equation. So to explain you the third equation, what I'll do is I'll go to a most generalized condition of the frames. Okay, so what I'll do is whenever you whenever you want to solve the reactions, what you do is that you take those individual elements first with respect to the external force. You calculate the reactions. Okay, with respect to external force, you calculate the reaction. The next thing is with respect to the end moments that you arrived at or which you have calculated. Using that also you will calculate the reaction. So the next thing is that you add these two reactions at any given points. So if you want to calculate the HA, what you do is that you add these two reactions. To calculate HD, you add these two reactions. Now you try to imagine now what is the next step to be done. Assuming let me call this as MAB. Okay, this is some value that we have had. Don't try to compare with this given figure. Okay, you assume some random frame. Okay, at random frame for these columns I have calculated how much is my end moments, which is MBA, MAB and MBA, and for this I'll call it as MDC and MCD. Okay, so if I tell you to calculate how much is the reaction at this point, what you do is that RA into length, which is L, plus of MAB plus of MBA, because the sign symbol that I am using are positive. Okay, is equals to 0. Similarly, you will calculate this. So if I tell you to calculate this reaction, you will write like this: MAB plus MBA divided by L. Okay, so neglect the sign conventions that we have. So to calculate RA, what you do is that MAB plus MBA divided by L you will do. For this, what you do, MDC plus of MCD divided by L. Okay, so this is your RA reaction, which is calculated by the end moments itself. Next step is that you calculate the reaction that you get from the external force. I am trying to draw a force which is arbitrarily placed, which doesn't have any particular portion. Okay, for this you can calculate RA, you can similarly calculate RD. Okay, so here what you need to understand is, if you want to solve the summation of horizontal force equals to 0, you have to calculate how much is the reaction from the movements, and you have to calculate the reaction that is from the external force, and you have to add these two. Then you will get to know what is the total force that you get here. Let me call this as HA. Okay, so HA is what? HA is equals to RA dash plus of RA. Okay, what is RA? RA is something which you have calculated from the external force, considering this to be simply supported. What is RA? RA is the reaction that you got from the end moments. Okay, and these are assumed end moments. So end moments is MAB plus MBA divided by L. Similarly for RD dash, what you do, if there is any external force that is acting on this column, you will similarly calculate RD dash. So here the net HD means what? Horizontal reaction at the joint D will be equals to RD dash plus of RD. What is RD here? RD is MDC plus MCD divided by L. Okay, now according to the equilibrium equation, okay, which is summation of horizontal force equals to 0, it means what? RA dash plus of RA plus of RD dash plus of RD will be equals to summation of external forces. This is what your summation of horizontal force equals to 0. Okay, you try to understand this. This is the most generalized condition I am writing. Now you can also assume this F1 to be UDL, this F2 to be UDL, or any other loading. Okay, so but the basic concept is same. First what you do, you calculate the reactions based on the end moments that you get, then you calculate the reactions from the external forces. Okay, then if you add these two, you will get to know how much is the horizontal reaction at this particular point, right? So by summing up all the reactions or the horizontal reactions and equating it to the external forces, you will get to know the summation of horizontal force equals to 0, right? So this is your condition. Now the same equation I have written here. Okay, what is RA means? RA means this equation, MAB plus MBA divided by L plus of MDC plus MCD plus MDC divided by L plus of RA is the reaction that we get from the external force. Let me call this as RD dash. Okay, RA dash and RD dash are the reactions that you get from the external forces. this should be equal to summation of F. Summation of F means what? These external horizontal forces. So this completes your summation of horizontal force equals to 0 equation. Okay, now coming to the condition of our given structure. In this given structure, you do not find any horizontal forces. If there are no horizontal forces, the summation of F is equals to 0. Henceforth, RA dash is also equal to 0, RD dash is also equal to 0. So what we are left with is like this. This is what the equation which is left with. Okay, MAB plus MBA divided by L plus of MCD plus MDC divided by L is equals to 0. This is what we get. Okay, now what is this MAB and MBA equation? We already know the slope deflection equation for MAB and MBA. So here what I'll do is MAB plus MBA divided by L. L is 6 meter, length of member AB, and similarly MCD plus MDC divided by L. L is the length of the member CD, which is 6 meter. Okay, so you already know MAB equation, MBA equation. Substitute here, divide by the length of the member. Now next is MCD, we already calculated. MDC is also been derived. So MCD plus MDC divided by L. Okay, so these equations I have resolved here. Okay, MAB plus MBA divided by L is this much, EI theta B by 6 minus of EI delta divided by 18. Similarly for MCD plus MDC divided by L also I have written the equation. Now I have to add these two equations. So I have added these two equations and I have written here. So the total summation of horizontal force equal to 0 for this given condition is EI theta B by 6 plus of EI theta C by 6 minus of 2 EI delta divided by 18 is equals to 0. Now this becomes my third equation. So what is your third equation? Third equation is considering that all the horizontal forces in the structure is equals to 0. Summation of all the horizontal forces in the structure is equals to 0. So we have three equations here. What is the first equation? Summation of all the moments at B is equals to 0. Next is summation of all the moments at C is equals to 0. Last one is summation of horizontal forces is equals to 0. And when we have these three equations, we have three unknowns, EI theta B, EI theta C and EI delta. I hope from now onwards what you do is you calculate the unknowns from your calculator. There is a method in which we try to solve the equations from the calculator itself. So I'll explain you later if you have any doubt. Okay, so after solving, this is the values that I get: EI theta B, EI theta C, EI delta. Substitute the values of EI theta B, EI theta C, EI delta in your slope deflection equations of MAB, MBA, MBC, MCB, MCD and MDC. Okay, after substituting all these EI theta B values, you will get the end moment equations. So for my MAB is equals to 9.515 and MBC and MBA and MBC are 23.8. MBA is positive, MBC is negative. Similarly for MCB and MCD, the value or the magnitude of moment is 20.62. The symbol is plus and minus respectively. Okay, the last MDC is minus 12.7. Okay, these are the end moments that I have calculated. You try to solve the reactions for this frame and also draw the shear force diagram and bending moment diagram for this figure. So if you have any doubt or difficulty in solving this, you message me and I'll try to resolve it. Okay, thank you.